Hi everyone, in this video, we'll go through Chapter 2 Worksheet number 3 on solving quadratic inequalities. So in this video, I'll go through how do you solve quadratic inequalities and how do you use a number line to represent the solution of a quadratic inequality. So let's start. Previously, we have always looked at quadratic equations, which is usually in the form of ax squared plus bx plus c equals to 0. So for this worksheet now over here, instead of an equation, which is an equal sign over here, this equation will now turn into an inequality. Inequality can be simply greater than or less than or greater than or equals to or less than or equals to. So these are the four inequalities that we have seen before, and we will learn how do we solve quadratic inequalities for today. Okay, so in order to solve a quadratic inequality such as, let's say, x minus 1 times x minus 2 more than 0, we are finding the range of values for x. We are essentially finding the range of values of x such that this whole equation here, this expression here is positive. Okay, so when we are solving quadratic equations last time, we only have two answers usually, but now because it turns into an inequality, we will have a range of values because of the inequality. So let's start by analyzing the following graph over here. Okay, I'm given the graph of this quadratic function, y equals to x minus 1 times x minus 2. So let's try. Mark and label the coordinates of a point A along any part of this graph here, along this smiley face graph, such that the y-coordinate of this point is positive. So we recap again, we know that the vertical axis here, this is your y-axis, this is your y-axis over here, the horizontal line here is your x-axis. So I will label this as my x-axis. Okay, so you can label any point that will simply have a positive y-coordinate. So let me highlight this in yellow. Okay, there could be many different answers for this. Try it by yourself. What is a possible point such that the y-coordinate is positive? If you notice over here, let's say I choose any random point. I can call this point here A, and this works because the y-coordinate of point A, which I wrote over here, is equal to 5, and this is positive. Likewise, let's say I now want to find a point B. Okay, let's say if I want to find a point B such that the y-coordinate is negative. I will simply look at my graph. Which part of the graph has a y-coordinate which is negative? I can see that it is any point that is between this range over here. So let's choose any point. Let's say I call the point over here, I just mark across over here. I can call this point B because the y-coordinate of point B is less than 0. Okay, so this is a very simple activity. So if I were to use a highlighter now to highlight the part of the graph whereby the y-coordinate of the points are positive and negative based on this smiley face graph over here. For all the y-coordinate being positive, I can see that based on my highlighter, I can highlight this entire portion over here and here whereby the y-coordinate is positive. Likewise, for the bottom part of the graph over here, we can say that using a highlighter over here, this bottom part here, the y-coordinate is negative. Okay, so very simply, this is a very simple activity to highlight that I can see using this highlighter over here, which parts of the graph have a positive y-coordinate, which parts of the graph have a negative y-coordinate. So if I now look at this inequality over here, this graph represents the equation y equals to x minus 1 times x minus 2. So if I were to look at this table over here, inequality, if I now have to solve the inequality whereby x minus 1 times x minus 2 is more than 0, it means I want to find a part of the graph that is above the x-axis, which is this part and this part over here. If it is more than 0, it is above the x-axis. So if I were to look at my graph, very simply, based on this diagram over here, the corresponding range of values of x for which I have the yellow color highlighted solution here and here is when x must be more than 2. You can see this value here is 2, this value here is 1. So in order to get the part of the graph that is above the x-axis, I must have from here, x must be more than 2 and x must be less than 1. So therefore, for this part of the solution here, the corresponding range of values for x is when x is less than 1 or x is more than 2. Likewise, if I have this inequality over here, whereby this graph that I have less than 0 means I want the part of the graph that is below the x-axis, whereby the y-coordinate is negative. I have the answer over here, which is this is below the x-axis. X must be between 1 and 2. Okay, and therefore when I use a number line to represent them, I can simply draw a straight line over here. Okay, number line, let's say I have these numbers 0, 1, 2, 3. Okay, x less than 1. This is x is strictly less than 1. This is a hollow circle, and it goes to the left over here. Oops, goes to the left over here. And x is more than 2, which is also a hollow circle, pointing towards the right. Okay. Likewise, if I were to have the same number line over here, to represent this set of solutions whereby x is between 1 and 2 is that I draw a hollow circle at 1 and 2, and I draw a line to connect these two circles together. And that is my number line representation for this inequality. Alright, so now let's look at practice this page number 2 over here. Can you try this by yourself? First, before I go through, you can pause this video. Okay, based on the following quadratic inequality here, find the corresponding range of values for x. Always remember, less than 0 means I want the y-coordinate to be negative, so it must be below the x-axis. More than 0 means above the x-axis. Okay, so I'll highlight that. Okay, you can pause this video now and try these 4 examples before continuing this video. Alright, so I'll now go through this part over here. First inequality, x minus 4 times x plus 2 less than 0. I know that less than 0 means it must be, it must be below x-axis. So therefore, I use a highlighter to highlight the part of the graph that is below the x-axis is this portion over here. And I can see that the x-intercepts is when essentially, how do we get the x-intercepts from this inequality? To find x-intercepts, it is the same as solving. To find x-intercepts, it is essentially just changing the inequality to an equal sign. X minus 4 times x plus 2 equals 0. Therefore, x is equal to 4 or x is equal to negative 2. So this, you can already see that from the graph. I'm just showing you how to know very clearly what the x-intercepts. This is 4. Okay, so therefore, very simply, the part of the graph that lies below the x-axis is when x is between negative 2 and 4. Okay. Likewise, over here, on the second inequality here, greater than 0. Greater than 0 means above the x-axis. Okay, so above the x-axis, if I were to use a highlighter to highlight, I will have this part over here and this part over here. And you can, to find the x-intercepts here, you can simply equate this equation equals 0. You'll get x goes to 1 or x goes to 3. Okay, so therefore, very simply, corresponding range of values of x that satisfy this inequality over here is when x must be less than 1 or x must be more than 3. Okay. Likewise, over here, this second portion over here, less than 0. Less than 0 means I want the part of the graph that is below the x-axis. Highlight will be this part and this part over here. Based on, by solving this equating this goes 0 to find your x-intercepts, you can see that my x-intercepts are, this part here is negative half, this part here is 4. So therefore, the corresponding range of values for x will be simply x is less than negative half or x is more than 4. Okay, and the last one over here, if more than 0 means above x-axis, I were to highlight this part of the graph over here. This is above the x-axis. X-intercepts are simply 1 and 5. So therefore, corresponding range of values for x would be x is between 1 and 5. And we are done with these 4 examples over here. Okay, so actually these things over here are very generic terms like x minus p, x plus q. Okay, I won't go through this part here, but essentially now that you can see how to solve a quadratic inequality instead. In order to do that, you must look at the inequality here first, then you can follow these steps over here. Make sure that the right hand side is 0 first, then we factorize, then we sketch the graph, then we can solve. So these are the main steps in order to solve a quadratic inequality, and with these steps you can easily solve for the quadratic inequality. Okay, so if we continue forward, if the inequality is less than or equals to or greater than or equals to, the corresponding range of values for x will also include the less than or equals to or the more than or equals to. Okay, so let's look at example 1 to explore how do we solve quadratic inequalities from here. Okay, so if you follow the steps, step 1, make the right hand side 0. Step 2, factorize. Step 3, sketch the quadratic graph. Then after that you solve. Okay, so actually I would like to summarize this using acronym which I like to use. I call this CFSI. What does CFSI stand for? It means cats fight snakes intensively. I find that this acronym helps me to remember how to solve quadratic inequalities. And if you see videos of cats, right, they actually when they see a snake, they use their paws to attack them very vigorously. So this actually helps me to remember this how to solve quadratic inequalities. But looking at the letters, C actually stands CFSI. Okay, oops, let me write it clearly. CFSI. C stands for check. Check right hand side is equal to 0. Second step, factorize. Third step, sketch. Last one, okay, last one is interpret. Interpret based on your sketch to find the range of values for x. Okay, so over here, let's look at example number 1. Okay, if I were to write my acronym over here, CFSI. Okay, first step, check. Right hand side is equal to 0. Factorize or solve or find the intercepts. Third step, sketch, and the last one is interpret based on your sketch. So let's look at example number 1. You can try this by yourself if you are confident on how to solve quadratic inequalities. If not, we'll work through this example together. Okay, example number 1. Step 1, make my right hand side 0. So in order to do that, I will add 10 to both sides of this inequality. So x squared minus 7x plus 10 is less than 0. So step 1, check right hand side 0, done. This part done. Next part, factorize. Factorize, you can use your tic-tac-toe method or the cross method to factorize this quadratic expression over here. By factorization, I will get x minus 5 times x minus 2, the whole thing less than 0. Factorize, done. Next step, sketch. We sketch a simple sketch of this graph over here of x minus 5 times x minus 2. I know that because my coefficient of x squared is positive, this is a smiley face graph. So I can draw a simple smiley face graph here. And the two x-intercepts is when I let this expression equal to 0, I can see that my two x-intercepts would be 2 and 5. Okay, so this is my x-axis. These are my two x-intercepts. Based on equating this equals to 0, we can solve for these two x-intercepts. Then my last part, check right hand side 0, done. Factorize, sketch ready. Last part is interpret. Less than 0 means I want the part of the graph that is below the x-axis. So if I were to highlight, it is this part of the graph over here. Therefore, final answer to this question, x must be between 2 and 5. And we are done. Okay, you can now try part B by yourself. Okay, remember, follow the same 4 steps and you can easily solve such questions. Over here is simply okay, so you can pause the video to try it by yourself first. Once you have tried, play this video to continue to check if your solutions are correct or wrong. Alright, now I'll go through part B. Okay, take note for part B, because even though I see a square, I cannot just square it, because if you square it, it is very different from an equation, you will lose solutions. Therefore, what I need to do is to first expand and simplify everything such that the right hand side is equal to 0. So by expansion first, I will get 1 minus 2x plus x squared less than or equals greater than or equals to 17 minus 2x. Then I simplify my left side. Okay, these terms here, I bring to the other side such that my right hand side can become 0. Okay, so over here, very simply, I will have, if I were to simplify, x squared minus 2x plus 2x will become, there will be no more x term. 1 minus 17 is negative 16. More than or equals to 0. Step 1 done. Step 2, factorize. X squared minus 16, this is a special identity. A squared minus b squared, I will get x plus 4 times x minus 4 greater than or equals to 0. Then next part, sketch. I know that based on my coefficient of x squared here, this is a smiley face graph. Smiley face graph, my two x-intercepts are, if I were to equate this expression to be equal to 0, I will get negative 4 and 4. Okay, so check. Right hand side 0 done, factorize done, sketch the graph done. Last part, interpret. I highlight the inequality. Inequality says greater than or equals to 0. It means above the x-axis. Okay, so answer to this question here is simply x must be less than or equals to negative 4, or x must be greater than or equals to 4. And we are done. Alright. Okay, so let's now move forward to the next part over here. A common thing that people like to do is that the moment they see x minus 1 times x minus 2 is more than 0, they straight away therefore conclude, therefore x minus 1 is more than 0, or x minus 2 is more than 0. Is this the right way to solve such inequalities? Let's explore this over here. Okay, if I have something times something equals to 0, we actually need to consider two cases. So let me just write it over here very simply. Two things multiply to each other. Okay, let's say, for example, for this expression here, let's say for this to be positive, when I multiply two numbers, for this number to be a positive number, I have two cases. These two numbers here, let's say, must be positive. Let's choose any random number, like 8 times 8. I'll get a positive number, 64. Okay. But if I want it to also be positive, there is also another possible case, whereby the other possible case is when the two numbers must be negative. For example, negative 3 times negative 5. Because it's negative times negative, I will also get a positive number like this. Okay, so you said there are two cases when I say that something times something gives me a positive number. Both the factors must be positive, or both the factors must be negative. So over here, if I want to solve this inequality here, I must have x minus 1 times x minus 2 must be more than, for this expression here to be more than 0, x minus 1 and x minus 2 must both be positive, or x minus 1 and x minus 2 must both be negative. So over here, based on this expression over here, we can see that therefore x must be greater than 1 and x must be greater than 2. Therefore, the common solution for this is when x is more than 2. Likewise, if I were to have both factors to be negative, therefore x is less than 1 or and x must be less than 2, the common intersection between these two is when x must be less than 1. Okay, so therefore over here, for this inequality here to be more than 0, okay, x must satisfy either case 1 or case 2. So therefore the solution to this would be x is less than 1 or x is greater than 2, which is the same answer as what we get. Okay, it's the same answer as what you can see over here. Okay, but I think generally, if you were to do this step over here, okay, this step here is a very big misconception. This is a misconception. Let me just write this down. Okay, do not try to go solve inequalities this way. Okay, because this is a common mistake that people always make. Something times something more than 0. It means that one factor is more than 0 or the other factor is more than 0. Because if you were to do such way, you have to consider different cases for this inequality to work, which is much more complicated and a bit harder to follow. That is why we always follow this step over here, CFSI. Make right hand side 0, factorize, sketch, interpret. Can follow this, you are able to solve all kinds of quadratic inequalities very easily. Okay? So this is a big misconception. Remember this because people like to always commonly make such mistakes like this. Alright, so now let's continue on. Let's look at example number 2. This is when things will start to get familiar with what we have learned previously. Okay, example number 2. Okay, the equation here has two distinct real roots. Find the range of values of p. So when you look at this question here, we see a keyword over here being two distinct real roots. We have learned this in worksheet number 2. Two distinct real roots, let me highlight this part over here. Two distinct real roots means that when I try to solve this quadratic equation here, whereby right hand side is equal to 0, I know that the discriminant of this quadratic equation d must be strictly greater than 0. So let's start by first making the right hand side of this equation here equals to 0. I first expand out my right hand side first to make it easier for me to simplify. 2x squared plus 4x plus 2 is equal to px plus 3p. Then I subtract px plus 3p from both sides of the equation. I'll get 2x squared plus 4x plus 2 minus px minus 3p equals to 0. Then from here, in order to simplify my left hand side now, I combine like terms together based on the power of x. So let me highlight my like terms so that you can visualize. 4x and minus px is a like term because of the common x factor inside the term. And 2 and minus 3p are also like terms because these are constants. So if I were to combine them together, I will get 2x squared plus 4 minus px, I can combine the x terms together, plus 2 minus 3p equals to 0. Okay, so in this resulting quadratic equation here, the question tells me that there are two distinct real roots. So what does that mean? It means that for this resulting quadratic equation, I know that for two distinct real roots, the discriminant d must be strictly greater than 0. Okay, so over here I know discriminant is b squared minus 4ac. To find the discriminant, we must first identify our a, b, c correctly from here. So if I look at my terms, I know that a is the coefficient of x squared, which is 2. B is the coefficient of x, which is 4 minus p, and c is the last constant term added to this quadratic expression. So over here, I write down very clearly, a equals to 2, b equals to 4 minus p, and c is equal to 2 minus 3p. So very simply, b squared minus 4ac must be strictly greater than 0. I sub in my abc over here. 4 minus p squared minus 4 times 2 times 2 minus 3p. This must be strictly greater than 0. So in order to solve this quadratic inequality, I must first simplify my left hand side. So by expanding and simplifying, I will get 16 minus 8p plus p squared. Then expand out all the brackets, I will get minus 16 plus 24p greater than 0. Then if I were to simplify everything further, I will get p squared plus 16p greater than 0. So now we go back to the steps that we have learned. CFSI. I know that C means check right hand side is equal to 0, which is done. Next step, factorize, sketch, then interpret. So very simply over here, now I'll factorize my left hand side. I'll get p times p plus 16 more than 0. So check done, factorize done. Next step, sketch. Based on this quadratic expression on the left side over here, I know that this is a smiley face graph, and to find my two x-intercepts of this smiley face graph, over here, we simply let this expression be equal to 0. Okay, very simply, okay, this one should be p lah, but it is the same concept of p-intercept. Okay, so over here, if I were to equate this left hand side equals 0, you will see that my two values of the x-intercepts in this case are -16 and 0. Okay, so if you cannot visualize, you can always write out at the side to help you understand better. P times p plus 16, p plus 16 equals 0. It means that p is equal to 0, or p plus 16 equals 0, which gives me p equals to -16. That is how I obtain my two values here for the intercept. Last part, sketching done. Now interpret. Interpret is based on my inequality of the graph. I see that this is greater than 0, means above x-axis. I highlight the part of the graph that is above x-axis. Therefore, final answer to this question is simply p is less than -16, or p is greater than 0. And we are done with example number 2. Alright. Okay, let's now move on to example number 3. You can always pause the video to try the example by yourself first. Then once you have tried, you can continue playing this video to see whether you managed to solve this example by yourself. Alright, so now I'll go through example number 3. Find the range of values of c for which the curve here lies completely above the line. Okay, so if it means this smiley face curve lies above the line, let's say this smiley face curve here, it lies above the line. So let's say if this is the curve y equals to 3x squared minus 6x plus c squared. This is the line y equals to 4. For the curve to lie completely above the line, this means that if I were to equate the curve and line together, which means that I equate 3x squared minus 6x plus c squared equals to 4, the discriminant of the resulting quadratic equation here must be less than 0, as there are no intersections between the curve and the line. So over here, discriminant must be less than 0 because for there to be no intersections between the curve and the line. Between curve and line. Okay, so therefore over here, in order to understand this, we first make the right hand side of this resulting quadratic equation 0 first. So very simply, 3x squared minus 6x plus c squared minus 4 equals 0. I identify my ABC very clearly. A is equal to 3, B equals to -6, and C is equal to, in this case here, c squared minus 4. So therefore, since I know that discriminant is less than 0, this tells me that b squared minus 4ac, -6 squared minus 4 times 3 times c squared minus 4 must be strictly less than 0. Okay, so from here, therefore I can continue to expand and simplify this inequality here. 36, okay, minus 12c squared plus 48 must be strictly less than 0. So therefore, this means that -12c squared plus 84 is less than 0. Okay, so now from here, how do I solve this quadratic inequality? Okay, let me shift this part a bit higher. Okay, so the steps are still the same as what we have done before. Okay, very simply over here, what I can do is simply, before that, I can actually simplify further. I see 12 and 84. Common factor is actually 12. So if I were to divide by 12, I can make this inequality easier to solve. I divide both sides by 12. Divide by 12, I'll get -c squared plus 7 less than 0. And therefore, if I were to divide by -1 on both sides of this inequality here, Okay, I can also make my c square coefficient positive to make it easier to understand as well. So c square minus 7 less than 0. If I were to divide both sides by a negative 1. Oh, but remember, when you divide an inequality by a negative number, the inequality sign must flip. So therefore, this part over here would be c square minus 7 must be greater than 0. Okay, and then we can now go back to the steps of solving quadratic inequalities. CFSI. First step, check right hand side is equal to 0. Done. Next step, factorize this quadratic expression over here before we sketch and interpret. How do we factorize this? Because you are A-math students, you have learned c square minus 7 is same as a square minus b square. But this 7 can be seen as square root 7 the whole thing squared. So over here by factorization, we can turn this into c plus root 7 times c minus root 7 more than 0. Okay, then from here, how to solve this quadratic inequality from this step over here? Remember, we cannot assume from here that therefore c plus root 7 is more than 0 or c minus root 7 more than 0. This is wrong. We follow the steps over here. Factorize done. My next step is to sketch. So now let's sketch the graph based on this quadratic inequality over here. By sketching, I can go ahead to the next step. Okay, first we sketch by this quadratic inequality here. C square minus 7 is a smiley face graph. The two intercepts, if I were to equate this equal to 0, I'll get negative root 7 and root 7. So therefore, by this inequality here, okay, this inequality more than 0. So therefore, it means above the x-axis. I highlight the part of the graph that is above the x-axis. Therefore, final answer to this question is that c is strictly less than negative root 7 or c is greater than root 7. Okay, and this is for example number 3. And we are done. Alright, let's now look at example number 4. Okay, the steps are very similar, so if you can start to follow, you can continue trying by yourself. Okay, example number 4 over here, I am given an inequality here. The first step is always to simplify everything. Okay, and we make it such that we can see the x squared term, the x term, and the constant term very clearly. So let's look at this inequality here. Find a range of values for m that satisfy this inequality. My first step is to simply expand and simplify. From here, I get 3x squared plus 3mx plus 6m plus 12 more than 0. Okay? So over here, I know that find a range of values. How do I solve this quadratic inequality over here? Okay, so very simply, since I know that based on the left-hand side of this graph here, 3x squared plus 3mx plus 6m plus 12. Since the coefficient of x squared is positive, this means I want to have a smiley face graph that is strictly above the x-axis. Okay, this will be the graph of, let's say, y equals to 3x squared plus 3mx plus 6m plus 12. The question is saying, I want this smiley face graph here. Okay, this smiley face graph over here to be above the x-axis. So how does that happen? This means that for the quadratic equation, if I were to equate the equation of the curve 3x squared plus 3mx plus 6m plus 12 equals to 0, the discriminant must be strictly less than 0 because the x-axis does not intersect with the curve. Okay, this is equivalent to the quadratic equation plus the discriminant of the quadratic equation being less than 0. Right, so now from here, let's work from this quadratic equation here and let's find the discriminant. We identify my a, b, c very clearly first. A is equal to 3, b is equal to 3m, c is equal to 6m plus 12. Alright, so therefore the discriminant is simply equals to 3m square, the whole thing square, minus 4 times 3 times 6m plus 12. This whole thing must be strictly less than 0. Then now I simply need to simplify my left hand side of the quadratic inequality. 9m square minus 72m minus 144 less than 0. Then I continue simplifying from here. M divided by n by 9, so I can make this quadratic inequality easier to solve. M square minus 8m minus 16 less than 0. Alright, so the steps are the same. We always use the same 4 key steps. C, F, S, I. Meaning we check right hand side is equal to 0. Then after that, we have simplified everything, we try to factorize. Okay, but actually in this inequality here, if you try to factorize, you realize that you cannot factorize this very nicely because there are no nice numbers to solve this expression here. So very simply, in order to solve this first, we must first consider the quadratic equation instead. For m squared minus 8m minus 16 equals to 0, let's use our quadratic formula to find out the the solutions to this equation. M is equals to negative b plus minus square root of b squared minus 4ac 1 times negative 16, the whole thing over 2a, 2 times 1. I'll get two solutions, which is negative 1.66 or 9.66 rounded off to 3SF. So this means that now when I didn't factorize this, but instead of factorizing, I used a quadratic formula to find my two x-intercepts here. Then from here, I can now move on to the next step, which is sketch. Okay, so to sketch this part over here, I can now move on to the next step. Since this is a smiley face graph, okay, based on my coefficient of m squared, I can draw a smiley face graph now. I know that the two intercepts are negative 1.66 and 9.66. So therefore, to answer the question, last part after sketching is to interpret. Okay, why did I write intercept? I just realized this one should be interpret, sorry. Interpret. Okay, so interpret this based on the inequality here. Less than 0 means below the x-axis over here. Therefore, final answer to this inequality is that, therefore, n must be between negative 1.66 and 9.66. And we are done with example number 4. Okay. Okay, next part. Example number 5. Okay. Example number 5, find the range of values of p for which this equation is always positive. So the steps are actually very similar. Okay, always positive means that for this curve, let's say I were to sketch out this equation here. Okay, y equals to this is for this curve to be always positive means that if this is my x-axis, the curve must always lie above the x-axis. Okay, this means that for this equation here to be always positive, this means that curve must always lie above x-axis. And for the curve to always lie above x-axis, there are actually two conditions. We know that for a curve to never touch the x-axis, the shape of the curve, it must be a smiley face graph. It cannot be a sad face graph because a sad face graph will always touch the x-axis. I know one condition is that 1. First condition, shape of the graph must be a smiley face graph. Okay, and for a smiley face graph, I know that this means that, therefore, coefficient of x squared must be positive, must be more than 0. Okay, and the second condition, okay, let me just centralize this. there's one more condition for a curve to be always positive. Secondly, this means that if I were to equate px squared minus 2x plus 2p plus 1, I equate this to the equation of this horizontal line here, which is my x-axis, equals 0. I try to solve. Okay, there must be no intersections. There must be no solutions. And for there to be no solutions, because the curve does not touch the x-axis, this means that the discriminant of this resulting quadratic equation must be less than 0. Okay? So, very simply, using these two conditions that I need to have. 1. For the shape to be positive, since x squared coefficient must be more than 0, this means that p, which is the coefficient of x squared, this tells me that therefore, p must be strictly more than 0. Okay? Second part, since I know that for a curve to always be positive, if I were to equate the equation of the curve, I equate it to 0, which is the equation of the x-axis being a horizontal line. There must be no solutions to this resulting quadratic equation here. So the discriminant of this quadratic equation must be less than 0. So let's first identify my a, b, and c. A is equal to p, b is equal to negative 2, and c is equal to 2p plus 1. So therefore, this means that the discriminant, which is b squared minus 4ac, must be less than 0. Then now from here, I can easily solve this. I'll get 4 minus 8p squared minus 4p less than 0. I divide by 4 on everything and I rearrange the equation. Okay, I'll get, let's say, over here, maybe let me rearrange first. Minus 8p minus 4p plus 4 less than 0. I can divide the whole inequality by negative 4. So by dividing by negative 4, I'll get 2p squared plus p minus 1. Since I divide by negative number, the inequality must flip to become more than 0. Let me highlight this in case you missed this out. It must flip from here to here because I'm dividing by negative number, negative 4. Okay, so then we follow the same steps again. From here, since right hand side is equal to 0, now we factorize this. By factorization, I'll get 2p minus 1 times p plus 1 more than 0. Okay, wait, I got no space. Let me make this a bit smaller. Okay. Okay. Yeah. So from here, then therefore, we follow the same steps again. Let me write out the side. CFSI. Check right hand side 0 done. Factorize done. Next step is to sketch. So by sketching, I know this is a smiley face graph. The two intercepts are negative 1 and half. So since it is the inequality, the last step is to interpret. Inequality here, more than 0 means above x-axis. The answer to this inequality here is p must be less than negative 1 or p must be more than half. Okay, so now I have these two conditions that must satisfy. P must be more than 0 and p must be less than negative 1 or p must be more than half. So therefore, since p must be positive, if I have to combine these two answers together, I see that p must be positive. So p cannot be less than negative 1. So therefore, final answer to this question. Okay, let me just write out the side. Therefore, okay, therefore from here, final answer, if I were to combine these two inequalities together, is that therefore p must be strictly greater than half. Okay, because even though this inequality gives me two solutions over here, since I got one more condition whereby the shape of the graph must be positive, therefore p must also be positive. Therefore, this p less than negative 1 will not work. I must have the only one range of values of x, which is p is more than half. And this is the solution to example number 5. Okay. Alright, now let's look at the last example for this worksheet over here. Okay, example number 6. I'm given the cost in thousands of dollars by this equation here. C equals to this whole thing over here. Find the minimum and maximum number of laptops that the company could produce in order to reduce the cost to below $20 million. Okay, so very simply over here, the cost C is in thousands. So if I want to have C below $20 million, it means that, let me write out over here, for C to be less than $20 million. So if I write out in dollars, 20 million. Okay, since C is in thousands, this means that C must be less than 20,000. Because C is in thousands, 20 million, therefore this means that C must be less than 20,000. So very simply over here, this means that I replace my C by the quadratic expression 0.03x squared minus 360x plus 100,000 is less than 20,000. So we follow the same steps. Make the right hand side 0. 0.03x squared minus 360x plus 80,000 is less than 0. So very simply, you see these numbers are very weird here. It's hard to find what is it's hard to factorize this. So I can simply use the quadratic formula to find the intercepts. So using the same methods again, CFSI, I've checked the right hand side is equals 0. Next step, very hard to factorize. So I'll use the quadratic formula instead to find the intercepts. For the quadratic equation, 0.03x squared minus 360x plus 80,000 equals 0. X is equal to negative b plus minus square root of b squared minus 4ac minus 4ac over 2a. Oops. Over 2a. 2 times 0.03. Okay, this gives me two answers, which is may I write out in at least 226.497 or 11773.5. Okay, so therefore if I had to go on to the next step, which is sketch smiley face graph, since coefficient of x squared is positive, the intercepts are 226.497. The other number is 11773.5. Okay, so I follow this inequality again. Less than 0 means below the x-axis over here. So therefore, this means that for this cost to be less than 20,000, the value of x, therefore, x must be between 226.497 or 11,773.5. Okay, so based on this inequality over here, it's very simple to identify. Therefore, minimum value of x is equal to, since x is bigger than 226.497, is 227 nearest whole number. Likewise, the maximum value of x is equal to 11773 based on the nearest whole number. Okay, I mean this is not the nearest whole number, but we are rounding down. Okay, based on the inequality, nearest whole number. Okay. Alright, so over here, since the question here say x is in hundreds, so therefore minimum number of laptops based on my x value here. Okay, therefore answer the question. Therefore, minimum number of laptops, since x is in hundreds, is equal to 22700. Well, the maximum number of laptops would be simply equals to 1177300. And that is the solution to the last example of this worksheet. Alright, so if you can follow, please go and try the practice questions now. Okay, you should be able to attempt the practice questions following how we have solved the example questions in this worksheet. Okay, and this will be the end of this video.